In this video, we're going to implement a stack as an array, and we're going to use it to reverse the order of input characters. We're going to use it to evaluate a postfix expression, and we're going to use a stack to convert an infix to a postfix. At the end of this video, what you should be able to do is combine the two functions. So the first function, evaluate or convert basically an infix to a postfix expression, and then using the second function that I'm going to show you, you're going to evaluate that postfix expression to find out what the result is. Okay, so let's get started. The first thing that we need to do is open up Visual Studio. Okay, so what we're going to do is we're going to create a new project, and we'll call it, make it a console app. And this one we're going to call stack as array. Okay, and I'm going to put it on the desktop. Okay, let's go desktop. Here's my example code. I'm just going to make a new file. Let's go like this. We'll say stack as array. Okay, and select that folder, and we'll start building. Okay, create. Okay, we don't actually need this stuff here. I'm actually going to remove this. But first thing, what you want to do is go into your folder that you've created. Okay, I'm going to just bring it over here. And what you want to do is you want to check where that, you see, stack as array.cpp. Okay, it's in this folder. So I want to create all my folders in here, all of my files in here. So I'm going to remove this one. I want to actually delete it. I don't really need that one. And I'm going to add, okay, let's see, new item, C++. I'm just going to call this, I'm going to have a main.cpp. Okay. And then what I need so I need to implement the stack as an array. So I need, okay, let's go add. We're going to have stack.cpp and stack.h. We need the interface and the implementation. So let's go here. So for in there we need we can use CPP if we want, but okay, so we're going to say stack dot cpp or dot c. I'm going to just leave it at dot cpp. And then in the header, I need a new item, and I need stack dot h. It's got to be the same capitalization. Nothing is capitalized. I'm going to use stack.cpp, stack.h. Okay, and okay, maybe it doesn't make sense just yet, but what I want to do is I want to define, okay, the items that go into each node in the stack. Okay, so what I need to do, I need to add a new item, and I'm going to call it item.h. Okay, so I'm going to call it item.h. Let's say if I want to do capital, okay, item.h, and this is going to define each of the items in the stack, okay? Because we might not want to just use, just integers or strings. We might want to define a structure. So we're going to define that here, okay? I'm going to say add. Now the reason I'm doing this, the reason I'm defining item.h is because later, in a later video, we're going to define our stack, or we're going to implement our stack using a linked list, and I want to use the same items, okay? I want to use the same elements. Okay, so let's do that. Let's rename this. I want to make this, let's go rename. Let's make it with a capital item. Okay. Cannot rename. There's already a file with this location. Okay. All right. Oh, I guess it's already there. Oh, it doesn't. Yeah. Okay. It doesn't matter. Okay, we're going to use item.h. Okay, that's fine. So what do we want to do first? Well, the first thing is we want to define what each item in our stack is going to look like. Okay, so let's go in and define what we want. So we're gonna have a structure. So we're gonna say struct. Okay, um, struct item is going to be defined as. Okay, I want like this. So I want to say a character, and it's going to be some sort of text. Item text. And we'll make room for 30 characters. We want a number. Okay. And we want operation. Okay. So we're going to define whether or not, what we want to use. We want characters, we want numbers, we want operations as part of the nodes, things that we can store in our structure. Now, when we do conversion from infix to postfix or evaluation of a postfix, in one of them we'll use number, okay, and in the other one we'll use the operation. Okay, so that's why I'm kind of putting these on. There's also text that can be stored, numbers basically, on the stack. Okay, so I want to have the ability to do each of these numbers or integers and operations. These are characters. Okay, it's going to be plus, addition, multiplication, etc. Okay, so I'm going to keep this. Okay, the reason again I have item.h is because, I'm going to use this structure when I implement stacks using linked lists as well later. Okay, so let's go in. When we implement a stack, right? Whenever we implement the stack, actually I forgot something here. If I don't want to write struct item every time I implement an item, what I need to do is I need to type def struct item. Okay, so type def says, okay, for this data type, I'm going to give an alias item. Okay, so what I'm basically doing is I'm saying wherever you see this, replace it with this, the definition for this. And struct item is defined here with a character, an integer, and another character. Well, a character array, an integer, and a single character. Okay, so this is the structure, what we can put, the things that we can put in our stack. Okay. Okay, I could have used a union, but I'm just keeping it simple and using a structure. All right, let's go into the stack. Now, what are the things that define a stack? Okay, okay. Before we start, actually, what I should have done was put, for every file, put a space, then star, star, star. Okay, what you want to do is you want to, because we're going to copy and paste this into a PDF. So we're going to say this is item.h, okay, and this define the structure of an item in the stack. So we could say to be used in various, right? In various implementations, right? Of the stack. Okay. So here I'll put by or author, Michael, etc. Right? And you can put date, whatever you like. Okay. So that's it for this one. So we can move this one out of the way. All right, so next what we're going to do is we're going to define our stack. Okay, so again, we're going to do pretty much the same thing. I'm going to grab, okay, so here we could copy and paste this if we like. Copy and paste here, right? I'm going to have to change this to stack.cpp and change the description. Okay, so implement a stack as an array. So this is the implementation. Okay, go like this, Control C. I'm going to do the same thing here. Okay, so stack.h, implementation of the stack as an array. Actually, this is the interface. Interface of the stack as an array. And again, we're using the class nodes. Okay, so this is based on class nodes. Okay, so I'm getting all this code from our class nodes. All right, so what we need to do, we need to include in here. Okay, we need item.h. Okay, and Control S. Actually, double quotes here. Okay, and all right, so we've got all that. Now we have to define. So we have to put the function prototypes, right? Okay, so this is where we're going to. This is the interface, so we have to define or declare the prototypes for our functions. So we say void init stack. Again, this comes from our nodes, max n. Okay, and what is this? This initializes the array for the stack, right? Initializes the array used to implement the stack, right? Implement the stack. Okay, so this initializes it. We have another helper function here. Int is stack empty. Okay, so this just checks to see if the stack is empty. Okay. Okay. Is stack empty? All right. And the reason why we have this green underline is because they haven't been implemented. Okay. So we have just the interface. It's looking in stack.cpp to see if it's been implemented. Control S to save everything. Actually, Control F5S would save everything. But anyway. Okay. So let's go to. Now we have the push and pop operations. Okay. So we have void, and I'm going to say stack push. Okay, and it is expecting an item, right? So the item is going to be passed to this function to be added into the stack, right? So this pushes item onto the stack. Okay. All right, and then we have the stack pop, which it has to return an item, right? Push takes an item as an input, right? And pop returns the item, right? This function actually gives us an item, right? Stack, and then pop, and then it doesn't take anything because basically it's popping from the head, right? The stack you push and pop from the head of the stack. So this is it returns. We can say returns or pops an item. Returns the item. How about that? At the head of the stack. Okay, so that's it. So this is our interface. Now these functions need to be defined, and we've given the definitions. We've given them in the lecture. So let's copy this and go to stack.cpp. Okay, if you're gonna copy and paste, remember to remove this these colons. Okay, maybe that's a good first step. And then what we need to do is we need to put our brackets. This is where we're going to define our function. Okay, and so let's do that just so that we don't make any mistakes. These are function implementations, right? Okay, implementation. I think I did it all right. Okay, and what we want to do is let's do this, and then let's take this Control X and just tab, 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 and just paste it there. Okay, so enter, enter, Control X, tab, 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 paste. Enter, enter, Control X, and then, okay, tab, 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 enter, enter, okay, and Control X, tab, tab, tab. Okay, you might notice that we have an issue here with item. It doesn't know what this is, right? It doesn't know what item is. So what we need to do at the beginning is include item.h. Okay, and then Control S will save, and there's no further errors. What you'll also notice is that, remember how it was underlined in green here? It's no longer underlined because the function definitions are here. Even though they don't do anything, they're defined, basically. They exist. Okay. So now what we have to do is we have to actually implement the stack using an array. Okay, so let's take a look at what that looks like. So here's our implementations. Okay. So what we need to do, we need to have a couple things. We need a pointer to the array. Okay, the array that we're using to implement the stack. And what we want to do is we want to keep it private to only the functions in this file. Now to do that, we use the keyword static. So static, okay, item. So this is a pointer to an item, and S is going to be the pointer to the stack array. Okay, so it's basically S is a pointer, right, to an item, okay, which would be the first item in the stack array. So this is the stack array, right? This is a pointer to the stack array. Okay, I can say pointer to the stack array, and which is an item. It's an array of items, right? An array of items. Okay. Now, S technically is global, but what we've done using static, we've limited, right, its use to, or its accessibility, right, or its scope to this file. Okay, so that's what we're doing here. And then what we need, the other thing we need is when we're going through the array, we need the index of the array. Okay, so let's put one of those. We're going to need that. So static int ISP. Now this code, again, it comes straight from the notes. I explained it in the notes as well. So this is the index within the stack array. Okay, and again, both of these are they're global variables to this file. We've limited their scope to this file by using static. Okay, so when we initialize the stack, what do we do? Well, okay, the input, we say initialize stack with a maximum number of elements, max n. So what do we need to do? We need to get S to point to the memory location that malloc will return. We need to allocate memory. So we're going to have malloc, okay? And anytime you use malloc, you got to remember, you got to cast the data type. So this is going to give you a memory location, but we want to cast it as an item pointer so that when we say S++, it goes to the next item. It goes down the memory, right? The number of bytes per item. Okay, so every time you increment S, it goes however many bytes there is an item per item, it goes down that location in memory. So we need to malloc max n. Okay, so this is the number of items, right? Times the size of, right, an item. Okay. Now, why is there an error here? Well, because we have not included the header that defines malloc. So we need to do that. In fact, what we should do, we're going to have some. Okay, here. Let me just include. Okay, and then malloc.h. That's our. So now malloc is good. There's no issue here. So we've allocated memory for max n number of items. Okay, and S now points to the first item. The next thing we're going to do is we're going to set our stack pointer to 0. Okay, so now the pointer, it's pointing at 0. Okay, now is stack empty? Basically what we return, again, this is straight from our code. If ISP is equal to 0, that means that it's empty, right? If it's true, if ISP equals 0, it's going to return true or 1, non-false. If it's not equal to 0, it's going to return false. Okay, it'll return a 0. Okay, we could have used Boolean here, but I'm just going to keep it simple. Okay, stack push and stack pop. Here we are. So basically, in order to push, we're basically going to push at S. Okay, we're using array notation. We push to the location of whatever ISP is, right? And then we increment the pointer. Okay, that's what this is. Okay, whenever the plus plus comes after, it means you increment after. If the plus plus came before, then you would increment before. Okay, so we're going to put it at the location and then increment the pointer. So we're going to put item, which was passed to the function, and then we're going to increment the stack pointer. And stack pop is the opposite. Here we return S, but first we decrement the stack pointer, right? Because this stack pointer points to the next available item, right? So we have to decrement because the next available item in the stack where you can push to, right? It's a free space. So you have to find the one that you already pushed, you have to decrement it, right? ISP and close. Okay, so we decrement and then because you have to decrement because the last place you push to was where there's an item. Okay, we incremented after we pushed up here, so the next item doesn't have anything in it, right? The pointer points to the next free item, right? Okay, so here we've implemented a stack as an array. Okay, so this is we have our interface, we have our implementation, and now we can actually start using our interface and our implementation. Okay, so let's go in, and here we're going to put our main line. So here I'm going to go, let's do this, space, star, enter, star, enter, star, enter, star. Okay, so this is going to be our main.cpp. So this is our client for implementing stacks as arrays, using arrays, okay? All right, so here we're going to show the different example here. We can put, by, the byline, etc. Okay, whatever, date, any other authors, etc. Where you got the code, you can put that all in here. Okay, so what we're going to do is we showed that you can use a stack to reverse order. We showed that you can use a stack to convert an infix to a postfix, right, expression. And we saw that you can use a stack to evaluate a postfix expression. Okay, your job at the end of this is going to be to combine the functions that I'm going to show you here in order to take an infix expression and evaluate it. Right? You first have to convert infix to postfix. That's one stack that you use, and then postfix to evaluate the postfix is the other stack. Okay, so that's going to be your challenge at the end of this video. Okay, so the first thing we're going to do, I'm going to show you three functions or three examples that we're going to use in main, and I'm simply going to use ifdefs to block them out. Okay, so int main. Okay, all right. Control S. Everything is good. Now at the end of main, I always like to just put a return of some sort. So return, and then 0. Okay, so we're already main already returned something. So how are we going to do this? We're going to go and we're going to look at three examples. Okay, so what I'm going to do here, I'm going to say define ex1. Okay, and then so I've already made this is just a and then I'll say define ex2, and then define ex3. Okay, so I'm going to do one example at a time. Okay, I'm going to show you the three different things. So here I'm going to say here if def ex1. Okay, then we're going to do the following things. Okay, and then we're going to say end if. Okay, that's our first one. And what we can do is we can just copy. I'm just going to tab this over, and I'm going to copy, paste, change this to ex2, tab over. So I'm basically, I could have separated this into three different functions, but what I'm going to do just to show you this is my first example is going to go here, my second example is going to go here, my third example is going to go here. Okay, do I have an ex2? No, okay, so it's not defined. So only this code is going to run first. Okay. All right, let's take a look at this, and then we'll see what we can do. So my first example is going to be to push back items in reverse order, right? So reverse the order of items, right? Pushed onto the stack. Okay. All right. So what do we need? We need an item. We need a variable to define an item. Okay. And then how many items? Items to start with. I'm going to initialize that to 0. And then I need an integer. Okay. I. And it's going to have a counter of some sort. Okay. It's going to be on my counter. Now, I noticed that I have item here as it's showing me an error. So I forgot to include, right? Include, right? And I need item. Actually, I need item.h, and I also need stack, right? Because I'm using the stack. Stack.h. Okay, Control S to save. Okay, if I need anything else, we'll add it as we go. Okay, so what we're going to do here, the user is going to, basically we're going to ask the user, right? Actually, let me do, this should be a part of the ifdefs here. Okay, the next thing we're going to do is ask the user how many items they want to input to the stack, have them input those items to the stack, and then we print it in reverse order. Okay, so ask user how many items, and basically push to stack. Okay, and then we return in reverse order. Okay, all right, let's do that. So first question we ask the user is printf. Okay, and it's got an error because I haven't included the header. So how many items would you, oops, make sure, would you like to push to the stack and reverse order on? How's that? Question mark. Backslash n. I should probably put a backslash n at the beginning here too. All right, just for nice. And then, okay, printf requires, we need, let's put it up here. So include, we need standard IO dot h, control S. Is printf working? Good. Okay. And what else can we do here? Now we want to use scanf. Let's see here. We want to use scanf. So let's take this guy, fix that. So scanf. Okay. And here we want a number. So %d. And where we want to store that is at the address of num items. Okay. And so that's going to go there. Now, this might generate an error because it doesn't like scanf. Look, see how it's underlined? It's let's see here. Oh, I forgot to. Yeah. Let's see here. Constcar. Yeah. Okay. Items equals 0. Yeah. Okay. That seems right so far. Okay. I want to see what's going to happen here because it doesn't like scanf sometimes because it's not the most secure function. All right, so let's go here and then we'll basically just end the program. I want to test it and see what we need. Test it in the middle. Okay, so run it. Let's see if it gives me an error. It says, okay, there's an error. No, I don't want to run from the last successful build. It's because of scanf, I'm sure. It's telling me that this function may be unsafe. We could use scanf underscore s. The reason why I'm not doing that right now is because I may want to use this function or this code in Linux, and I just want to make sure that it's portable. Some functions may be portable to the compilers in Linux. Some of them may not. I'm not sure if scanf.s is portable. So I'm gonna stick with scanf. Just so in order to do that, see what it says here: to disable deprecation, so it's deprecated. Use CRT secure no warnings. So that's what we're gonna do here. We're gonna go define CRT secure no warnings. Okay, so Control S, and now it would be that's one. Okay, so this is an error. My item is an unreferenced local variable. So let's go back here. My item is unreferenced. Okay, we haven't used it. I is an unreferenced, so we never used it. Okay, that's okay. That's fine. I can deal with that. Control S, and let's run and see if it compiles. Okay, let's go here. And how many items would you like to push to the stack in reverse order on? Let's say 10. And program should end. Okay, good. All right, so there's no compilation errors yet. All right, so let's go on. So now that we know how many items are in the stack, we can initialize the stack, right, as an array. So we're going to make room. So init stack. And then here we're going to put the value of num items. Okay. So remember, this passes, scanf needs the address of a variable. Here we actually passing the value of that variable. Init stack, there we go. The spelling was incorrect. All right, now what we want to do is one at a time, push items that the user, right? The user is going to enter some text and we are going to reverse the order of that after. Okay, so first we need to take in each item in the stack. So we're going to do that in a for loop. Okay, and so I equals 0. Okay, I less than num items, right? Because that's how many items are pushing to the stack. And then I plus plus. And then open. Okay, so now what we're going to do is we're going to read, right? Read one item at a time. So here, what we're going to say is we're going to say printf, and what I'm going to do is here I'm going to say enter. Go backslash and enter some text. Okay, and here I'm going to say backslash n. Actually, if I do this, I don't want to put too many spaces. I just want to go on the next line. So enter some text. Actually, I could do it. Let's see what this looks like. Enter some text. Okay, enter your line there, and then same thing, scanf. Okay, and now it's going to be a string. So we're going to take a string, %s. Okay, and we have to write to the item. That's why we design our item. So it's my item, right? Now, my item has things that you can write a number, you can write an operation, or you can write a string. And that's what I want. I want to write to item text. ITEM item text. And then close. Now, look, my item text. So item text is the name of the character array, right? So it's a pointer, right? It's a pointer. This is a pointer. So my item, the item text variable, this is a pointer to the array. And that's what scanf wants. It wants an address, right? It writes to an address. It needs the address that it's going to write to. So that's why we wrote it like this. Okay, so once that happens, once you get the text, then you can push, right? Push item to stack. So that's what we're going to do. Say stack push my. We're going to push the whole thing to the stack because that's everything, right? Even though we didn't fill num and the number or the operator with anything, we're just using the text in this case. Okay, so this is going to reverse the item, and then once we're done, we can then output, right? So we could say, let's go print f, right? And we're just going to tell them that we reversed their items. So the text you entered, we'll say now in reverse order is, right? And then put it on a new line. And then what we'll do is we will basically while. Okay, we're going to have a while loop and we're going to output until the stack is empty, right? So while the stack, empty, okay? So while the stack is not empty, right? Is stack empty while it is not empty, okay? Then we're going to print what's on the stack. Now, I must have done something because it should, while this should give me, okay, there we go. So then we're going to print f. We're going to print what's on the stack, right? So we'll just say, we'll just say stack pop, okay? And then this gives, so stack pop returns what? This returns an item, right? But what do we want? We want the actual, so this returns an item, right? So we have an item, so we go dot, so this stack pop is like the name of the item, dot item text. This is a pointer to the first character in the array, and printf looks for the string termination character, the \0, right? So when you pass printf a character array, it's looking for that. So that's what we're doing, and then that's it. What we might want to do, is probably space it. Let's just go like this. Let's go %s, okay? And then what we probably want to do is put spacing in between our words. Maybe we'll do it like that rather than backslash. Maybe, you know what? Let's go \n. Put them on different lines, okay? All right, so that is that. And then that's it. So that's where we're going to stop here for this our first function, okay? This is the reverse order of items pushed onto the stack. Okay, so this is our, maybe what I'll do is do it like this. Like that. Okay, so now we'll save. Okay, and we're going to run this example. All right, let's save again, and we'll test out our example here. Okay. How many items would you like to reverse, well, basically push to the stack in reverse order on? Let's say 6. Okay, enter some text. How are you today? I am. So it's in reverse order, right? How are you today? I am. And then done. Okay, so that's our first example. Again, it's going to complain that we have this is here, a return value ignored. There's something here. It's looking for a character, but I'm giving it a number. I'm just reading it in as a number. Okay. Okay, so this is good. The next thing we're going to do is we're going to do some of the examples that we had in the lecture, and that is we need to we're going to convert from Infix to Postfix. Okay, so now what I'm going to do up here is I'm going to take this one and comment out the first example. So now this is what's going to run. Okay, I'll save all. So I want to run this example. Okay, so here is I'm going to convert from Infix to Postfix, right? Okay, so let's do that. So what do we need in this example? I'm going to have a loop of some sort. So obviously I need the loop counter. I need an input character string. So car A. And I'm going to give it a string here. So I need to have, obviously, the brackets on the outside. So I have 20, right? Oops. I have 20 plus 15. Okay. And then this is my string that I want to evaluate. And then I have int n is strlen a. I need to know the length of this string because I need to know how many times. Now, because I'm using strlen, I need the string headers. Okay, so I need string.h up here. So I'm going to say include string.h and save. Okay. So that's what I need there. So int n, and let's see. Okay, so now what I can do, okay, I need to make a stack to put these characters on, right? So I'm going to follow along. So init stack. And how many items? We need n items on our stack. Okay, so that's our the size of our stack. And then I need to define my items. So item, my item. Okay, we're going to use this temporarily. We need it as a temporary, and then we'll say printf. Okay, converting infix expression to postfix. Okay. Um, let's just do that. We'll just leave that and we'll say \n. Okay, so now we have to implement the algorithm that we developed, right, for conversion. So for I equals 0, I less than n, I plus plus. Okay, so this is our for loop for everything. Okay, so we have our cases here. So if a at I, okay, if it's a right round bracket, then this is a single line if, so print f, and here I'm going to say %c, okay, and then I'm going to stack pop dot operation. I spelt it wrong. Stack pop. Okay, and I'm taking the operation, right? It's an operator. Just make sure it's there. So look, you say stack pop dot, and then you can select, okay, from the struct. Okay, and then we are going to close that. Then if it's an addition or a multiplication, so if we encounter if a at I, right, equals is the addition, or a at I is the multiplication operator, then we have to actually perform that operation. So we say my item dot operation equals a at I. Okay, and then we push that. Sorry, we're actually pushing that operation to the stack. So we say stack push my item. We push the whole item to the stack. Okay, and then if it's a digit, that's when we output it. Okay, so here we're going to, so if is digit, wrong function, digit. Got to go back to see what it looks like. Is, oh, this one, okay, this function comes from, it's a function that's defined in a header. And let me see, is it in, I think it's C type. Let me try it. Include C type.h and see if that, let's go down here. It recognizes, okay, it recognizes the function now. Okay, so let's go down. So if the character that we see is a digit, right, then what we want to do is print it. It gets printed to the output. Printf %c, okay, and then we print that character out. Okay. If it's a space, then print a space. Okay, we're gonna put that in there. If a at I is a space, then just print the space. Printf, just printf a space. Okay, and that's it for all characters. So let's recap. As soon as you encounter the right round bracket, that's when you actually print you pop from the stack and you show it basically, right? You print that operation. If it's an operator, you push the operator to the stack. If it's a digit, you print it out directly. If it's a space, you print out a space. Okay, that just keeps things looking nice. And then that's it for all the operations. And we might want to let me put another printf \n \n. Okay, just to be nice and clear. Okay, so Control S or save everything, and let's see. So let's see what this, if this prints out what we want it to print out. It should give us the postfix expression. So let's go and print it off. So converting from an infix expression to postfix, we have 20, 15, and 1. And plus, and we have the correct conversion. Okay, so that's good. That's a great example. And so the next thing we're going to do is, once someone has converted an infix expression to a postfix expression, it's then possible to take that postfix expression and evaluate it using a stack. And that's what we're going to do in example number 3. So let's do, if we have a postfix expression, okay, so here we're going to have 20, 15, and 1. We're going to evaluate that postfix expression. Okay. All right. So let's do that next. All right. So in example 3, we're going to start with the postfix expression that we have and evaluate a postfix expression. Okay, and then your job is going to be to combine these two examples. All right. So let's go to, we need the actual postfix expression. So car a here equals, we said 15 and 20 and plus, right? So let's do that. So we say 15, 20, and plus. So we're starting with what the output of the other one was. Okay, so this is our postfix expression to be evaluated. Okay, all right. So we're going to evaluate this. We should get 35. All right, so we have to do the same thing we did before. We need the length. We're going to put everything through a for loop. So int n equals strlen of a. Okay, so we need how many times we have to go through the loop. We need a loop counter, and then we can start. So same thing as before. We initialize the stack, and we know how big it is now because we know the size of n, how many characters on the stack, and then we're going to go through one at a time those characters and actually evaluate, right? If we find an addition operator, we pop the top 2 items on the stack and actually add them. If it's a multiplication operator that we encounter, we pop the top 2 items and we actually multiply them and then push the result again to the stack. If we encounter a digit, then we have to check to see, are there 2 digits? Like a 10 would have 2 digits, and you'd have, the first digit is a multiple of 10. We keep multiplying because we're using decimal notation. And I explained this in the class. So here is the for loop. So we have a for. So I equals 0, right? I less than n, and then I plus plus. Okay, so now we have to input all of the possibilities and what we have to do. So if a at I, right, is the plus symbol, right, the addition symbol, then we actually have to do the addition, right? So then my item dot num equals, right, stack pop, right? We have to pop the number off, right? Plus, okay, stack pop again dot num. Okay, so we pop the top two items and we add them together and store them in the myitem.num. Now, did I define the myitem? No, I did not. I missed that item. This is temporary, right? My item. Okay, this is just temporary. It's temporary variable, right? So this is temporary used for addition and multiplication. Temporary variable used in addition and multiplication operations. Okay. So we did this one, and what we can do for the next one is, oh, I forgot to, so once you add them, you have to actually push it. So we're going to say stack push, we got to push back onto the stack, my item. Okay, that's it. And what we can do, because addition and multiplication are basically the same, I mean, just changing the sign, so copy it and then paste and change to multiplication. Okay, so that's good. And the next step is we have to do the conversion if it's a number. Okay, so we actually have to convert from ASCII cars to integers. Okay, so for example, we have a 1, right, gets, or 1, 5 gets converted to 15. Okay, that's basically what we want to achieve. Okay, so let's go in there. And so basically what we're doing is we're seeing if what we're seeing is a digit, then we have to do the conversion. So if is digit, okay, a at I, okay, then what we have to do is we have to do these conversions. So we say my item dot num equals, okay, so this is the first part of the number, equals a at I, okay, minus the character 0. Okay, and we saw that, whatever character this is, if you subtract 0, then the actual number that you push to the stack is the difference between this ASCII character and 0, and that actually turns out to be, like if a at I was the character 7, and you subtract character 0, then the result of that difference between those two values is going to be 7. Okay? All right. So basically, this is how you convert a character into an actual integer. Now, the problem comes when you have a number that has more than one character. How do you deal with that? Well, we know that as soon as you move a number to the next column, right? You go to the tens, the hundreds, you're multiplying by 10. So we need to multiply. If there's another character that comes after the first character, then it's a multiple of 10, right? Or a power of 10, actually, right? A number of times that you do this. So the first thing I have to do is push this character or this number, right? My item, okay, the whole item, okay, push my item to the stack. Okay, and then I'm going to pop it and use it if there's another. So while there's another character, right? If the first character, if it's 10, right, you'd have a 1, and then the next number would be, or the next character is another digit, then we have to multiply the first one by 10. So that's what we're going to do. So while there are more digit characters, right? So while is digit, okay, a at I, plus 1. So the next one, basically. We're looking at the next. While the next character is a digit, then what we're going to do is we're going to multiply the first one by 10. So what we have to do is my item dot num. So the new value of the number is going to be equal to, now we have to take that first digit that we popped onto the stack, multiply it by 10. Okay? And pop, so we're going to take that, multiply by 10. Okay? So that's the first thing we're going to do. And then what we're going to do is we're going to take the next digit, that next digit. So what we have to do is we have to, so here we haven't actually incremented, we're just looking, right? But here what we have to do is we have to go a at plus plus I. So we have to increment, right? Increment and then, right? So we have to increment I and then take the difference between that incremented, the next character basically, and we take away 0 again. Okay, so we're doing the exact same thing as what we did before. So now we're converting that second character into a number, and we're adding that value to the first character, which was multiplied by 10. Okay, so we're actually getting its value. And then when we're done, we push the result, stack, push, right, my item. Now, if there's a third character, this algorithm still works because you're multiplying the value of the first two by 10, right? And so, if it was 150 and you got the first two characters, the result after the first loop would be 15. Then you'd multiply that 15 by 10 and add the third character, say it's 0, so it would be 150. Okay, and you push that value to the stack to the number. Notice that there's a number that we're looking for. Okay, that's basically what we're doing. Okay, so we have the result, and then what we can do is we can give the user the results, right? So we say print f, and so really once you get to the end of the stack, right? Once you've gotten to once you've done the evaluation, here, let me just close this for a second. Once you've evaluated, you've popped and pushed and popped, and you get to the end of the expression, there's only one number on the stack left. And so when we print, all we have to do is print, pop a number off the stack. There's only going to be one, and that's the value of the evaluated expression. So we say the expression evaluates 2, and then we could say %d if we want. Okay, and then I might go \n, \n. Okay, maybe I'll do this as well. Okay, and the expression evaluates 2. Okay, and then what we could do is we could just say stack pop dot num. Okay, that's what it evaluates to, and then Control S, and let's see what happens here. Okay, so so this one takes in a string and it evaluates it. All right, let's see what happens. Okay, do we have an error? Let's see. Nope, everything looks good. So no, it's giving us an issue because it's popped. The expression evaluates to 15. So we have an error here, or we have something. There's something wrong with the code here. So we're going to have to take a look and see what the issue is with our code. Okay, let's go through and make sure the expression evaluates. So we are running example 3. Let's just make sure that I'm using example 3. Okay. Save. So example 1 is not running. Example 2 is not running. Example 3 is. You see how it's colored purple here. So I have 15, 20, and plus. Okay. Correct. Okay. Okay, I found the error. This is inside the for loop. So Control X, put it there. Okay, Control S. Let's run our code. And let's see here. Okay. Right, close. Okay, so if we run our code, the expression evaluates to 35, which is what we expect. Okay, so we have evaluated. Oops, I shook the. Okay, so we've evaluated our expression. 15 plus 20 gives you 35. Okay, let me grab that code again. Okay, so this expression evaluates to 35. So now your job is going to be to take the first example and combine it with the third. Okay, so that's going to be the next thing that you're going to do. Okay, we'll leave that up to you. I hope you enjoyed this video. In another video, what I'm going to do is I'm going to take stack.cpp, this implementation, and I'm going to implement the stack using a linked list. Okay, that's going to be in our next video. We're going to modify this in order to use a linked list.